Now we've already seen how to deal with a quadratic function that has been written in vertex form. But what happens if our quadratic function is not in vertex form? Well, we can complete the square, or there's an optional trick. So let's recall what it means to complete the square. So we have two terms of a polynomial, and we want to write a third term so that it would be a trinomial square. So if we look at the areas, the area of this square is x squared. The area of this green rectangle is 10x. But what we're going to do is we're going to write this so that so let's go ahead and divide up this green rectangle so that we have two rectangles that are 5 by x. So here we see x squared, we see 5x, we see 5x. So what would it take to make this a square? So the whole thing would need to be a square. So what square can we add right here? Well, the dimensions are 5 by 5. So we need 25 to be added to it. So where did this 25 come from? It came from the 10 divided by 2 and then squared. So we're going to take f of x equals x squared minus 6x plus 1, and we're going to complete the square to write it in vertex form. So we have f of x equals x squared minus 6x plus 1. That plus 1 is not what we need. So let's group the first two terms and just focus on those. Now we'll still write the plus 1. But now, how do we complete the square on x squared minus 6x? So we have x squared minus 6x. We need to add something. What can we add? So remember, we're going to take the 6, we're going to divide by 2, and square. And that's going to be an addition of 9. So what we've done is we've added 9 on the inside. So we need to balance that on the outside by subtracting 9. Now what we have within the parentheses is a trinomial square. So that trinomial can be factored into x minus 3 quantity squared. Now we have plus 1 minus 9. That gives us minus 8. So now this means that h is 3 and k is negative 8. So the vertex is 3, negative 8. We have an axis of symmetry that's a vertical line, so we will write x equals, don't forget x equals 3. So we found the vertex, we found the axis of symmetry. Now, is it concave up or down? And so you'll notice that the coefficient of this is like a 1 in front there. So that's positive, so it's concave upward. And then we have to graph the quadratic function. So let's graph the vertex, 3, negative 8. It's concave upward. There is no stretching. And so we have our parabola that looks like this. Okay, so now let's take a look at the next quadratic function, and we will do the same thing. F of x equals, now what we will do is we will again group the first two terms. But now, we do not like having this negative 3 in front of the x squared. If you remember back in our picture of completing the square, we had a square that was x by x. So this negative 3 is standing in our way. So let's go ahead and factor out a negative 3 from inside the parentheses. So negative 3 times x squared. Now the question is, negative 3 times what is negative 10? Well, it will definitely be a positive number, and it will be positive 10 thirds x. So negative 3 times positive 10 thirds will be negative 10x. So now this is still plus 5, and now comes the completing of the square. Negative 3 times x squared plus 10 thirds x, and now we need to add something. What do we need to add? Well, we take the 10 thirds divided by 2. That would give us 5 thirds. Square it. 5 thirds squared would be 25 ninths. So we have this plus 5. Now the question is, how do we balance on the outside what we've done on the inside? Now let's be careful, because this 25 ninths is weighted. This 25 ninths is being affected by the negative 3. So what do we really have here? It's negative 3 times 25 ninths. So this is really a negative 25 thirds. So we need to balance that by adding 25 thirds. So now we have negative 3 times, and now we have that trinomial square can be factored into x plus 5 thirds, quantity squared. Now 5 plus 25 thirds is going to be plus 40 thirds. So this gives a vertex of negative 5 thirds, comma 40 thirds, an axis of symmetry of x equals negative 5 thirds, and it's concave downward. So let's plot the points. We have negative 5 thirds, which negative 5 thirds is negative 1 2/3. And then 40 thirds is 13 1/3. So we're actually off the coordinate plane here. So negative 1 2/3 and 13 thirds would be about here. And we're stretched vertically, so it's rather hard to see this because we don't have it on the coordinate plane. So I'm just going to go ahead and do this. Now, there is a trick. So if you have a quadratic function in the form ax squared plus bx plus c, then h is going to be negative b over 2a, and you can find k by plugging that value into f. So let's take a look at an example. So h would equal negative b over 2a, which means that h equals negative b, so negative 16 over 2 times a. So this ends up being a positive 16 over 4, so we get 4. So what's k? K is going to be f of 4. So we get 2 times 4 squared minus 16 times 4 plus 26. And that gives us negative 6. So this means that we have a vertex of 4 comma negative 6. We know that this is concave upward because we have a positive 2 leading off. Our axis of symmetry is x equals 4 from our vertex. We can find any intercepts. So let's find the y-intercepts first, or y-intercept first, by letting x equal 0. So f of 0 is going to be 2 times 0 squared minus 16 times 0 plus 26. So 26. So our y-intercept is y equals 26. Our x-intercepts, we'll let y be 0. So we have 2x squared minus 16x plus 26 equals 0. We can divide everything by 2. And this yields for us x squared minus 8x plus 13 equals 0. Now, this does not factor. So, we'll use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So now this gives us 8 plus or minus the square root of 64 minus 52 is going to be the square root of 12. So the square root of 12 is 2 square roots of 3. Now simplifying, we can factor a 2 from the numerator. So we have 4 plus or minus the square root of 3, all multiplied by 2, all divided by 2. So we end up with 4 plus or minus the square root of 3 as our x-intercepts. Now, whenever we're looking at the domain and the range, the domain of any quadratic function is all real numbers. The range is found by thinking through this. Vertex is 4, negative 6, and it's concave up. So this is the lowest point, and it's concave up. So I know it's the lowest point because it is concave up. So the lowest value is negative 6, and it goes up from there. So the range is negative 6 to infinity. Now, where is it increasing and where is it decreasing? Well, since it's concave up, that's found, if we think about a concave upward function, it's concave up, meaning the vertex is sitting at the bottom, so it's decreasing before the vertex and increasing after the vertex. So it's increasing after 4, and then it's decreasing before 4. Now, lastly, where is our function positive? Well, for this, it might be beneficial to think of it graphically. So we have this graph, and its vertex is at 4, negative 6. And we have 4 plus the square root of 3 and 4 minus the square root of 3 as the intercepts. So there's 4 plus the square root, that's 4 minus the square root of 3. And this is 4 plus the square root of 3. So where is y bigger than 0? So where is f of x bigger than 0? It's bigger than 0 whenever we are to the left of 4 minus root 3. So negative infinity to 4 minus root 3. And it's also bigger than 0 to the right of 4 plus root 3. So these are the x values, where is f of x smaller than 0, or is it negative? And that will be between the two x-intercepts. So between 4 minus root 3 and 4 plus root 3.